Hello, I'm Lisandro Mathers, and in this video I will walk you through what's new in version 4.50 of HELYX and ELEMENTS, Angel's open source CFD solutions. In this version, we have added full GUI support for a feature introduced previously, the distance-based refinement using edges extracted by a specified angle. This makes it much easier to refine curved surfaces without having to create manual volumetric refinement regions. We have also extended the reference frames functionality. You can now define user-defined base mesh and material points in local reference frames. For material points, we have improved the interface when multiple material points are enabled. You can now add a linear range of points, import and export points lists from and to CSV or Excel, and sort points alphabetically. These may seem like small changes, but they are very useful for large cases with many regions created via multiple material points. Previously, for a given patch, you had to choose between surface refinement or volumetric refinement. In version 4.50, you can apply both surface and volumetric refinement to the same patch. For multi-region cases, we introduced the pocket zone grouping option, which lets you group cells in disconnected regions into a single separate zone. Still, for multi-region cases, we added the option to split a mesh using cell and face zones without the need for mapping. Unlike the previous split mesh feature, this new version can also split patches by face zones. This is available through a drop-down menu using the Split tool under the Region tab in the top bar. In the Setup tab, the main enhancement is the introduction of multi-physics support by modularizing the modeling panel in the object browser. You can now define different physics and solver settings per region within a single case. This is fully aligned with the unified solver framework of HELYX Core, which enables HELYX to run multi-physics simulations. The next step in the graphical user interface is to allow solving any physics in any region simultaneously within the same case. So, for example, you could have one fluid region solving a compressible flow, another fluid region solving a multi-phase flow using the VOF approach or the Euler-Euler approach, and both fluid regions coupled to a solid region to solve a CHT case. We have improved the solar radiation model by allowing the solar direction to be specified as a time-dependent function table. This extends the previous options of constant and time-tracking solar directions. Still talking about radiation, we have extended the discrete ordinates method to wedge and symmetry models, including a specular radiation boundary condition that supports axisymmetric and symmetry plane computations. And we have also added GUI support for local solar transmissivity. We expanded the existing convective heat transfer boundary condition by allowing non-uniform environmental temperature for convective walls. We added full GUI support for the cavitation models that were previously available only via HELYX Core. We have introduced new functionality to support partially overlapping non-conformal coupling boundaries, allowing cases where some boundary faces do not have neighboring faces and require specific boundary conditions. A new partial overlap option has been added for cyclic non-conformal couplings to enable this, with configurable settings for non-overlapping faces defaulting to wall. In compressible buoyant flows, static pressure previously had to be obtained via custom fields that subtracted the hydrostatic head, which is difficult when density varies across a boundary. HELYX 4.50 simplifies this with a new field process that automatically computes static pressure using specified reference densities and heights. This removes complex workarounds and provides the static pressure field directly. We have also improved the solver charts by allowing tabs to be displayed as tree objects. For multi-region cases, the graphical user interface now creates separate graphs for each region and lists them as child elements under the residual section, improving organization and readability. We have developed a new native HELYX case reader that loads cases about 4 times faster and uses roughly 1/4 of the memory compared to version 4.40. In the video, you can see a comparison between this new version and the previous version. We had added options to use linear, logarithmic, or user-defined ranges for isosurfaces. We have also significantly improved the slice widget interface, giving much more control over interactive translation and rotation of slice objects, and we introduced a multi-slice option to create multiple slices based on also linear, logarithm, or user-defined ranges. For streamlines, you can now use multiple sources to generate streamlines. Previously, you had to create one streamline object per inlet source to see all streamlines entering the domain. Now you can generate them at once, which is particularly useful for cases with multiple inlets, such as data centers. We have also improved the 3D view controls by introducing a cube object to manipulate the camera, which enhances the 3D navigation experience. In addition, you can now add text directly into the 3D display, which is very useful when generating images for technical reports. Finally, we introduced several general graphical user interface improvements, such as a better interface for working with points, such as multiple material points, zones, and volume probes, a search filter for drop-down menus, which is very useful for cases with many patches, and a surface picker tool that helps identifying coupling patches more easily. Both HELYX and ELEMENTS version 4.50 are available for download from our customer portal. There you can also access the documentation, including a complete list of the new features, improvements, and bug fixes for this release. And lastly, if you're not a customer but want to learn more about Engis and our open source CFD solutions, feel free to contact us through our website or reach out to anyone from Engis on LinkedIn. Thank you for watching, and I look forward to seeing you in the next release.